Let us live in gratitude and offer to you our thanks. Thank you for this group of people who share your heart of service. Thank you for the fellowship we share, whether in person or on an online chat. Protect our families, communities, nation, and world. Strengthen our hearts and resolve, and most of all, our trust in you. Amen.
Amen. Amen. Thank you. Where's Gary?
I'm here.
You got it.
Okay. Jackie's pulling up the flags, I believe. They hadn't come up yet. There it is.
There we got it.
Okay.
Face
Great to
the
see
elegante.
everybody. That's right. Everybody would please join me in the pledge to our great nation. I pledge allegiance, to the flag
of the
the United States of America, and to the republic which it stands, one nation, under God, indivisible, liberty and justice
for all.
Now to our great state of Texas. Honor the Texas flag. I
Pledge allegiance to the Texas, one state under God,
one and indivisible.
one and indivisible.
Thank you.
Thank you.
If everybody will mute your microphones except for
Okay, you ready? And to introduce our guest speaker today, we have past President Ted Moore, Managing Director at Higginbottom Insurance. You've got it, Chad.
Okay. First, I want to do a shout out to Tim Sedella. I'm sure he's at home taking pictures of his computer monitor for all of us to see later on. But our guest today is Andrzej Stewart. He's an experienced spacecraft operator for a wide variety of NASA missions. He's worked as a spacecraft mission controller for the Spitzer Space Telescope, Juno, Grail, and NASA's Mars Orbiter Fleet. Andrzej now works in mission control in Johnson Space Center, training as a navigator for the upcoming Artemis missions of the Orion spacecraft. He is a first lieutenant in the Civil Air Patrol, serving with the Texas Wing Emergency Services Training Officer, and also as a search and rescue disaster recovery mission pilot and aerial photographer. Andrzej earned degrees in aerospace engineering from the University of Texas at Austin and Massachusetts Institute of Technology, and aspires to be a NASA astronaut. In pursuing that, he served as a flight engineer for the Hera C2M2, a 2-week asteroid mission simulation at the Johnson Space Center, and as chief engineer officer of the High Seas 4, a year-long Mars simulation in Hawaii. Thank you for coming, Andrzej. We're looking forward to your speech.
Sure, and I'm glad to be here. And the first thing I'll say here is normally I'm used to giving this presentation to folks who might not have so much experience with isolation. Over the past few weeks, all of a sudden, we've all become experts. So this is going to be a little bit of a different experience for me. But at the same time, I hope y'all still get something from this. And at the same time, maybe see some things apply to the things that are going on right now. But that being said, we've all been kind of locked up for a few weeks now. Might be a good idea to go and take a little trip, at least virtually anyway. So I'm going to go ahead and pull my slides up here. And let me see. Go to screen sharing. Let's see, where did that go? Sorry, it'll be just a moment here. Okay. And can everybody see the slide?
yes.
Okay.
Yes.
Okay, so I'm going to take us on a virtual journey to the planet Mars. And like any good journey, you've got to start somewhere. So why not the International Space Station? So if you're an astronaut on the ISS, this is the view out your window. And that's one heck of a view right there. You can see kind of the Earth in all its glory. This is taken from one of the modules called the cupola. And you know, we think of space being very far away, but whenever you're in the space station, you're only a couple hundred miles up. It's about the distance from Houston to Dallas. And as it turns out, if you've got a strong enough telephoto lens, you can very literally see your house from there. So this was a photo taken during Expedition 24. So an astronaut floated over the window, pulled out a camera, attached a lens, and took this photograph. And in that circle right there is the Johnson Space Center. So that right there is home for the astronauts. I'm actually just kind of to the right of that. So where I'm talking to y'all from right now is in that photograph. So even from space, you can still see home. But we're just getting started on our journey. So let's keep going. So we're moving on out now. So this was taken during Apollo 17, which was the last mission to the moon for the Apollo program. And we're far enough out now that we can see all of the Earth. So we can see the curvature of the Earth. This is a very famous photograph called the Blue Marble. And that being said, you can still see a lot of the trappings of home. You can see land masses, you can see the ocean, you can see the clouds, you can see the weather patterns. But we're still just getting started, so let's keep going even farther. This time, another famous photograph called Earthrise, and this was taken during Apollo 8. So the Apollo 11 mission was the first mission to land humans onto the moon, but Apollo 8 was the first mission to take people at least around the moon. So we did a bit of practice around the moon before we actually landed. And so as far as humanity goes, this is about as far out as humans have ever been from their home planet right here in this photograph. You can still see Earth though. You can still see those clouds. You can still see land masses. You can still see home from here. All right, now let's hop across the solar system. So we've never put humans onto the Martian surface before, but we do have a robotic presence. And so this was taken from a rover called Curiosity. And Curiosity is an atomic-powered rover, landed a few years ago, and after its first year of operation, it was commanded to point its camera back towards Earth and take a photograph. And if y'all are looking for it, there it is. You are here. So all of a sudden, we're a long way from home. And that's actually something that could be a big stress for the astronauts. Being isolated, which y'all are coming to understand now, just kind of all the stresses of being isolated, being farther away from home than we've ever sent people before in the history of humanity. And NASA wants to do this. We want to explore the solar system, but you know, it'd sure be nice if we could practice before we did it. You know, if we could learn about all these problems and come up with solutions and ways to solve them before we had to do it, that'd be, you know, really nice for those astronauts, make it easier for them. You know, it'd be nice if we had sort of a Mars on Earth here that we could practice on. Well, it actually turns out we do have that. And so these are a couple of the facilities we have here on our home planet Earth that we use to train to send people out to deep space. The one on the right is called the Human Exploration Research Analog, or HERA, and that's actually here at the Johnson Space Center. So there's sort of a nondescript hangar on the east side of the Space Center, and that's inside. It used to be a facility that was taken out to the desert to practice technology and things like that, and it was after it was used there, NASA Johnson Space Center got a hold of it and have turned it into this isolation study. They've run, I want to say, has it been 21 missions now in there? And with that facility, I've actually spent time in that facility. So I spent a 2-week-long mission in there in fact, it was in a couple of days, it'll be the 5-year anniversary of our mission start. So 5 years ago, almost to the day, did a 2-week-long mission in there, simulating a mission to an asteroid. And I enjoyed that experience so much that I decided to do it again. And so on the left side, there is another facility. This one's in the state of Hawaii. So it's on the northern slope of the Mauna Loa volcano. And this one's called the Hawaii Space Exploration Analog and Simulation. And this was a little bit longer. So instead of 2 weeks, I was there for 366 days. So a whole year. And again, even though it was a different facility, a longer mission, still studying sort of the same key concepts. How do astronauts work together as a team? how they deal with the stresses of being separated, of being isolated in a small space for a long period of time. And even though these are on Earth, they do a good job of making it kind of as realistic as possible. And so here's another view of high seas, and you'll notice it's really isolated out there. So the mission is simulated, but the isolation is very real. And so what you're seeing there again is the northern face of Mauna Loa, all that sort of barren lava rock. It's very convincing. You look out the window and it almost looks like the planet Mars. You'll also notice that it's the only thing there for miles in any direction. So there's no Target, no HEB to go to whenever you need to buy something. So you kind of have just what you take with you. And I'll talk a little bit more about that later. But at least it kind of gives you an idea of kind of how isolated it really was up there for this year-long mission. Now, I'm talking about these facilities, and I promise these are the only words I have in the presentation. Mostly they're here, so I remember the words. So these are kind of my notes here. But high seas and HERA are a classification of something called an isolated and confined environment. You can kind of add all of our houses to this definition now, but even before this, we had a lot of things that filled this definition as well. Things like submarines out in the ocean, the space station, Antarctic research bases, and they all share a few characteristics. For one, they tend to be remote. So if you think about the space station, it's in space. Or those Antarctic research stations are on another continent entirely. So they tend to be very remote, not near society. And because of this remoteness and sometimes the environment, they're difficult to get to. So to get to the space station, you can't just get in your family van and take a drive. You have to take a rocket to get up there. HERA was, being on Johnson Space Center was easy to get to, but high seas, it was about a half-hour drive up the mountain over rocky terrain and things like that. It was sort of, there was only one way to get there. So facilities like this are usually difficult to access. They're often isolated and confined because they're in places that are dangerous. Again, a submarine under the ocean, you can't just open the door and go outside because you're in water, you're not in a breathable atmosphere, you're in crushing water pressure depths, things like that. If you're in Antarctica, you're in extremely cold environments. Space is a vacuum. So these places tend to be in places that are not conducive to human life. And because of all these factors, you don't get to go outside very often. And if you do, you usually have to wear some sort of protective equipment. So astronauts have to put on their spacesuits, or Antarctic researchers have to put on multiple layers of clothing. If you're in a submarine underwater, sorry, you're just stuck inside. You're probably not gonna be able to get out for a while. And so rather than having sort of a whole world around you, you've kind of taken everything and crunched it down into a very small space. And then finally, and this was an important factor, especially for the research we're doing, whenever we pick people to go to these sort of places, we're not necessarily picking people who knew each other or who were friends or family beforehand. We're selecting people because they do a certain job and they're really good at it. So we're trying to pick, for the space station, the best scientists in the world, the best doctors, the best teachers. But they don't necessarily get along straight away. And so for us, it's rather than taking a family unit, it's getting a group of people and learning how they work together and how they can stay working together under a stressful situation for such a long duration. Now, I've been talking about the isolation and I've started getting to the crew here. At this point, I'd like to kind of introduce you to my crew. So for HERA, which was the 2-week mission, that's my crew to the left. So from left to right, that's me. I was the flight engineer for the mission. Our 2 mission specialists are in the middle there. So Linda Royburn is Air Force National Guard working as a battlefield commander. Shana Gifford is a doctor out in St. Louis. And then Ethan Good on the right is our commander, and he's actually a flight controller at Johnson Space Center as well. He's what's called a visiting vehicle officer for the International Space Station. And so from my 2-week mission to my year-long mission, and for the year-long mission, we actually had an international crew. So again, from left to right, Cyprien Verseau is from France, and he's an astrobiologist. Next to him is Christiane Heinecke from Germany, and she's a physicist and was our chief science officer. Carmel Johnson there in the middle was our crew commander, and she's a soil scientist from Montana. Tristan is an architect from Montana who was studying at the University of Hawaii at the time. Shana Gifford again as our crew doctor, and then me on the far right as the chief engineer for the mission. And what I want to stress here is, especially for that photo on the right, those 5 people were the only 5 people I spoke to directly or saw for that whole year. So none of my friends, none of my family, it was just me and those 5 other folks. So we'll talk a little bit about that too. But first, I kind of want to talk about the facility itself because it's kind of a unique experience all on its own. And part of that, as I mentioned before, whenever I showed you all that big wide angle of the facility, there's nothing out there except for what you take with you. And because of that, things take on kind of a different value. And so one of the sort of running jokes along the mission was we would joke with each other, hey, I bet you $20 that this thing will happen. Or I bet you $20 that he's going to do this. And the joke was that $20, you couldn't spend it anywhere. In space, money doesn't have a whole bunch of value anymore. The things that do have value are the things that keep you alive. So your resources, water, power, and time. For a real space mission, air as well, but because we're on Earth, we didn't have like an airtight environment, so that wasn't something we had to worry about so much. And at Hera, because we're again at Johnson Space Center, those weren't limited, but at high seas, it's very much off the grid for real. So all electricity is generated on site. You see in the top left photograph there, a solar panel, and that's what generated most of our electricity for the mission. This habitat kind of doubles as a green energy sort of laboratory as well. And so that powered us most days. The bottom right is a hydrogen fuel cell we would use as a backup for really cloudy days. The problem with that backup, though, is you see those tanks. If you use it too much, eventually those tanks run out. So that was something we used only when we absolutely had to. For the most part, we used that solar panel. And because of that, it really sort of dictated how we ran our day. And so that's what I mean whenever these resources have a value. So if it was a cloudy day, that may mean that maybe we didn't get to have a hot meal that night. Maybe we had to eat something cold instead. Or especially in the winter when the days weren't as long, maybe that meant we couldn't turn on the heater as early in the day as we wanted to, and would maybe need to throw on an extra layer of clothing or hide under a blanket for a little bit. Water is a big thing for astronauts and people here on Earth as well. So water you do a whole bunch with. You clean with it, you cook with it. It's required to stay alive. You have to drink a certain amount of water every day. And it's heavy to launch into space, 8 pounds per gallon. And people go through multiple gallons of water per day. So on the International Space Station, they actually recycle their water, and I mean all of their water. So perspiration, for example, that you sweat off is caught by an air filter. It's filtered, it's cleaned, and put back through the system. And there's other sources of water that I won't mention in polite company that get recycled and cleaned as well. It's expensive technology. So for us, we didn't have a recycler, so we had to limit our water usage as much as possible. And so those tanks in the top right, that was about a 5 to 6 week supply. And they would send a truck up every once in a while to refill it, but we'd have to plan about a week in advance, keep track of how much water we were using, and send messages to Mission Control letting them know that, hey, this day we're going to need a water refill. And then they would send the trucks up. We'd have to close the windows so we couldn't see outside because they didn't want us seeing other humans while we were up there, and they would refill those tanks. So we took extreme measures to save the water there. We'd do what were called Navy showers, where you turn on the water for a second or two, put on some soap, and then you've got about 1 minute of water to wash yourself down. Note that you don't necessarily get to wait till the water is warm first. So you might get a cold shower if you're the first person that day. We would reuse water. So we had bowls in our sinks. Now, whenever we would wash our hands, we would capture that water in that bowl, and that became mop water later in the week. with all this, and for some other reasons too, we were able to get down to 24 gallons per day water usage. And so that's 4 gallons per person per day for everything. So that's 4 gallons to drink, to prep food, to clean, to shower, 4 gallons per person per day. To compare, the average American uses about 100 per day. Now, it helps that part of that is because we didn't have a swimming pool to fill or a front lawn to water or things like that. But that kind of helps show sort of the extreme measures we're taking, again, because that water has so much value. Without it, you don't have a mission anymore. I'll breeze through this slide really quickly, but with all those resources and other things you have to keep track of, a habitat like this, it's like living in the most advanced smart home you may have ever seen before. So we had sensors around the habitat that would measure how much power we had in our batteries, how much water we had in that tank, how much we were using. We had temperatures. There was a carbon dioxide measurement in the hab, and our mission controllers said they could actually tell whenever we were exercising in the dome because they would see that CO2 rise because we were breathing more heavily. But that takes me to another thing. So we did have a mission control team, and we did have a way to communicate with friends and family at home, but it was delayed. And there's a reason for that. And so we're going to talk about how big the universe is. So for high seas, we were simulating a Mars mission, and Mars is a long way away from Earth. Whenever they're as close together as they get, they're 55 million kilometers away. Light, at the speed of light, going as fast as it can, still takes 3 minutes to cross that sort of distance. And radio waves are just a form of light. And so whenever you send a radio signal from Earth to Mars, it takes at least 3 minutes. But it gets longer, though, because that's when they're close together. Whenever they're as far away as they get, it's 401 million kilometers, or 22 minutes now. So whenever you send a signal from Mars, it can take anywhere from 3 minutes to 22 minutes to get there. And so imagine what a phone call would be like. Let's say you're on your Mars base and you pick up the phone and you call Mission Control in Houston. You say, "Hey, Houston, we just woke up for the day. How's the weather in Houston today?" And so Houston, after 20 minutes, gets your message and says, "Okay, we're doing great here. Weather's a bit cloudy today. It might rain later, but we're having a great day. How's Mars today?" Then you wait another 20 minutes, and then you get your message back. So it's taken 40 minutes already, and all you've done is say hi. Conversations that take minutes on Earth, once you get into deep space, all of a sudden start taking hours or even days, just because of that time delay. And it's really difficult to communicate as well, because we're learning this more now while we're doing this meeting, in fact, and you can see my slides, but I don't know if y'all can see me or not. But there's so much of our language that's beyond just words. There's how we speak, the stresses we put on syllables, our body language, things like that, even the words we select. All of that conveys meaning. And then whenever you take a lot of that away, and so you make it just a radio signal or just a text message, you take away a lot of the meaning. It becomes much harder to communicate. And that was something we noticed as well, is that we would have to choose our words very carefully in emails we would write, just because a lot of that context was lost, and you couldn't go into a room and grab somebody and talk to them because of that simulated distance we had. So I make it sound very difficult, but there's a lot of sort of good things that come from this too. Part of it is that you can kind of control the information that you're having come at you. So being sort of back from this mission, you realize kind of how much in real life we have information coming at us all the time. We have social media, we have TV, we have radio, and it's sort of almost this constant stream of data coming at us. And being on a mission like this, I say, is almost like being in a monastery, because all of a sudden the only information you get is the information you ask for from mission control. There's no sort of water cooler discussions with people you haven't seen in a while. You're not just going to randomly get on the internet because there's no internet at that distance. And so you kind of can control what you listen to. And for us, we were on a mission dedicated to science. And so we requested that Mission Control send us science news and things like that. And so for us, for Hera, it was 2 solid weeks of science. For High Seas, I lived science for a year. And so it gave me the chance to kind of focus. The other thing too is distractions. Being that far away, you get to be kind of, we'll say, more productive. I'm like anybody else, you know, I'm working. Sometimes I just want to take a break and go on YouTube and watch a video. You can't do that when you don't have YouTube available anymore. And this happened to us. We would go on, try and log in somewhere, and then all of a sudden realize, oh, we don't have the internet. We can't do that. Well, I guess I'll get back to work then. So it helped us really kind of motivate ourselves just to keep working. We'll talk a little bit about that in a couple of slides too. So I've kind of talked about what the facility is like, but let's talk about what life is like too. And y'all are getting a taste of what life is like in isolation as well, but we have a couple of things on top of that. And so we didn't just go to these habitats just to kind of live there and have like a year-long vacation. We were there to actually do specific work. And for us, that work was science. And it's the same reason we're going to send people to Mars. You know, we don't want them to just go and hang out on Mars, you know, take a few pictures and come back. We want them to get some science done. And for us, that was no different. So NASA was doing studies, again, on psychology, on crew coherence and things like that. And High Seas, being a year long, was long enough that we could take some of our own studies as well. And you can see some of the studies here in the top left. Being an engineer, I wanted to work on robotics, so I took a drone, something that you could use to access places that a suited crew member wouldn't be able to. So I used that to go take pictures of the top of our dome to check for maintenance issues. You could fly that over rough terrain to inspect it before you walked on it. To the top right there in that photograph, that's our crew doctor working on rescue procedures. What happens if an astronaut tears their suit or injures himself? What do you do to get them back to the habitat where you can work on them safely? In the bottom picture, you see Tristan working with plants. We had a lot of crew members who grew plants while we were there. Talk about that in a slide or two as well. One difference between what we were doing and what a real astronaut would do, though, is we were doing this science activities, what are called flight-like activities, to accomplish the same thing that astronauts do. So, for instance, whenever we were doing geology tasks, we were trying to do geology and, you know, measure the environment around us. But we had a little extra dimension in that NASA wasn't just seeing what we would get from that geology, but was measuring us at the same time. So there were a lot of surveys and things like that. And it wasn't necessarily that they were grading us. It wasn't like an A through F grade, but they wanted to see the effects of the stress, see if things changed over time. And so it was, we were still doing the science, but at the same time, we also were the science as well. So I'd mentioned some of that geology, and another thing whenever we send people to Mars is we don't want them to just live in that dome, but we want them to get outside. We want them to dig in the dirt. We want them to take samples and measure the land around them. And so for High Seas, because we were out on that rocky environment, a couple of times a week, we would put on the simulated spacesuits, go outside and do geology. Or sometimes we'd have to go out and fix the habitat. Things would break. The habitat was about 3 or 4 years old by the time we got to it. So about the time whenever things start running out of warranty. So we'd have to go out and fix things. We had a couple of crew members who had experiments that required them to go outside as well. And that being said, even though we were on Earth, we still put on simulated spacesuits. On Mars, because the atmosphere isn't breathable, astronauts will have to put on the suits to protect themselves, and so we wanted to do that as well. In a lot of our crew photos, you'll see those yellow suits, and those are just repurposed hazardous material suits. They're not very realistic. You just kind of get into them and Velcro them up, and you're in. A real spacesuit's much more complicated. It's essentially a self-contained spacecraft. But we did have a couple of simulated, more realistic ones as well, and so those are the white suits you see. The downside to that one is they're much more expensive, so everybody had their own hazardous material suit, but we only had 2 of those, what were called MXC suits. The other downside was they were designed for somebody about a foot shorter than I am. I was the tallest crew member, so I couldn't wear one of those outside. If you ever see me in a photo in one of those, what you don't see is somebody behind me holding the backpack up to make it look right. But those white suits also had a lot more realistic systems. So it had a fan to move air through it. It had a water tank, and you'd wear a vest with it, which had tubes running through it, and you'd plug into the backpack, and it would run that water through the vest to keep you cool. So systems that are very similar to what a real spacesuit has. Now, as I mentioned before, there's no HEB nearby, so if something breaks, you have to fix it. Also, it's whenever people say, oh, your mom doesn't work here, same thing applies there as well. So whenever you think of astronauts, you tend to think of the cool things they get to do, like flying in jets or going out on spacewalks and things like that. But it turns out that astronauts have to do everything that you do as well. So there's sort of the glamorous side to it and the not so glamorous side. Whenever I'm talking to groups of junior high and high school students, I tell them, hey, you know, if your parents make you clean your room, they're just training you to be an astronaut. It's on the space station, for example, they don't have like a janitor crew they send up. Believe me, if they did, I would be the first person to sign up for it, because I'd be a space janitor. That would be pretty cool. But everything falls to the astronauts, so you still have to do the things that you do at home as well. That means cleaning the bathrooms. At the bottom left there, Tristan's got a bucket of pine shavings, bulking material for our composting toilets. And you can tell by the look on his face, he's not enjoying that job, but it has to be done. If things break, you don't have a store you can go to take a replacement. So at the top left, that's me fixing one of our stoves. We had a spare unit in the back that had some parts that were broken, and that one had just broken. And so in that picture, I'm taking bits from each of these two units and putting them together so that we've got a working stove again. We could ask Mission Control for one, but it would have been several months before they've gotten there. I like to talk about the food a lot, because while you're there, and we might be at the point here in our isolation for coronavirus that y'all are starting to kind of hit a rhythm. You're getting into a place where it's starting to feel more familiar. You've kind of got sort of a daily routine now that was probably different from what you had before. And our mission was like that as well. You know, the first couple of weeks, especially for the long mission, first couple of weeks, you're getting used to stuff, but by about a month in, you know, you wake up on a Wednesday morning and get your spacesuit on because of, you know, that's what we do on Wednesday. We go and spacewalk on Wednesday. You know, it just becomes kind of normal, as weird as that sounds. But for me, the food was something that kind of was the reminder that, hey, you're doing something really weird here. And we had raw food, and NASA flies food for astronauts that lasts a really long time. From the time you package the food in Houston, get it on a rocket, shoot it into space, and then for Mars, because you have to take with you, it can be months to years before you eat this food. The food has to be packaged in a way that it lasts a long time. And so a lot of that's done through freeze drying. The top right there looks kind of like packaged sort of packing peanuts. That's actually shrimp cocktail. That's before you add the water back. And so what you do with those kind of foods is you plug them into the water system, you add water, and as you're adding that water, it kind of becomes food again right before your very eyes. It's almost like a magic trick. And so you take it, you mix it up, you Velcro it to a wall somewhere, you wait 15 minutes, you come back, and it's done. What I'll say about the space food is it's actually not as bad as it sounds. So space food has a bit of a bad reputation. During the early space program, like Mercury and Gemini, the food actually really was bad. I mean, we're talking about food out of toothpaste tubes, or what they called food cubes. You had like a cubic block of gelatin and other flavored material, and food back then was really bad. That was actually a problem, was they couldn't get astronauts to kind of eat enough calories. So that being said, they've had several decades to get it right since, and the food is not that bad anymore. You miss kind of fresh fruits and vegetables, because a lot of the vegetables, in order to make them last, are freeze dried, and you add the water back and it makes them just kind of mushy. So you kind of miss kind of the crunch or the crispness of like an apple or a carrot or something like that. But aside from that, the food's pretty good. There's actually a couple of recipes I've gotten from the food lab and made at home. There's a really good lemon curd cake, and I've even made that for a work party and it was a dessert competition and it won second place. So the food's not bad anymore. Now for high C, oh, and I'll say, so that food there, that's the same food they eat on the space station. Because Harrow is at Johnson Space Center, we basically got food right out of the ISS food lab. It was sort of their spares that they weren't going to fly, and so we were eating the same things as the astronauts. Now at high seas, because it's more of a university project, we didn't have the ISS food lab, so it was more like camping foods, meal prepper sort of things. So the top right was a lot of what we had was these massive cans of like freeze-dried chunks of meat or cheeses or vegetables, and you could kind of add water to them and they would become whatever they were supposed to be again. And we had a full kitchen at High Seas. So High Seas originally started as a food study and then expanded to do everything else. So we had a full kitchen there, and with enough creativity, you could actually get some interesting foods there. So the bottom right is our Thanksgiving dinner, and that there is a real pumpkin pie. So canned pumpkin lasts a while, flour lasts a while, spices last a while, and you have water. Mix those together, throw them in the oven, you get a pumpkin pie. That turkey there, though, you got to have a little bit more imagination with that. So for that, we took one of those cans of turkey chunks, added water and flour, and then kind of shaped it into a thing that looked like a Thanksgiving turkey. It's not as good as the real thing. Tasted more kind of like a turkey flavored chicken nugget. But that being said, you know, you're on a mission like this, you feel lucky to be there, you're willing to make a few compromises. And it still wasn't bad, just not as good as the real thing. I'd mentioned fresh foods, and because we're at High Seas for a year, we had time to actually grow some foods while we were there as well. So the bottom left was actually our first fresh food harvest. I think that was about 2 to 3 months in, and so we got cherry tomatoes. So not like full-size like dinner tomatoes. Those were tiny little like one-bite cherry tomatoes, and for us, this was a huge event. So we got our best clothes on. I was in shirt and tie, you know, sort of the fanciest clothes we had on us. We set the table all formally, and we each had a plate with a cherry tomato on it. And we sat there trying to get as many bites as we could out of it because it was the first fresh food we'd had in 3 months. And so for us, that was a big sort of landmark. From then on in the mission, it wasn't something we had every day, something more every week to 2 weeks, we would have some fresh food. And that helped keep morale up, and kind of, again, it had that crunch and that crispness that you kind of miss. And part of the reason it was just an occasional thing is food takes up a lot of space to grow, and we just didn't have room to grow enough food that we would have been able to do it every day. So for us, it was more of just an occasional treat rather than a daily thing. We found that lettuces, chard, sort of leafy greens were the easiest to grow. If anybody's read or seen the movie The Martian, we did try potatoes. Unfortunately, we were not as good as Mark Watney. Our potatoes failed, and that was because we just didn't have the space for them. We didn't have the water drainage. So Mark Watney beat us, but we at least had our leafy greens. I've talked a lot about work and a lot of the hardships and things like that, but what I'll say is astronauts, we think of them as, you know, these amazing people, but they're really just people. I mean, we didn't grow them in a lab anywhere. They came, they're just like you and just like me. They're still people at heart, and they still need time to recharge and do their own thing. We learned that during the Skylab days. We pushed a couple of crews there too hard, and they kind of stepped back a day and said, hey, we're gonna stop all our procedures for the day. We just need a day to catch up. And the lesson was learned. And so on the ISS, they run 5 days a week, and the weekends are kind of theirs to do with what they want. And so the same thing was modeled for us in that we had some downtime. We found we were doing tasks every day, but we still had time in those days to kind of catch up and do our own things. I found a lot of my crew members, they're very sort of motivated individuals. So a lot of them were working on learning things. We had a couple of crew members learning languages. Cyprian down there's got that ukulele, and he had never played a uke before. And so he got that the day we went in. There's a guitar shop in Hilo he got that from. And I'll tell you, the first couple of weeks in there were kind of painful to listen to, but by the end of the mission, he was pro. So a lot of sort of just, I guess, the people who gravitate to this kind of thing just kind of naturally want to push themselves and learn stuff. We also did group activities. The top left was a staged photo. We thought it'd be funny if we did that, but We did do board game nights on Wednesday nights. You can see the screen behind us there. And so we had a projector, and we would use that on Friday nights. We had a server full of movies we could watch, and so Friday night was movie night. One of our crew members knew how to salsa dance, so Tuesday night was salsa dance lessons. So we did have fun while we were there as well, as real astronauts will as well. And I'm coming to the end of my presentation now, but I do have a couple of photos, just kind of some of my, I guess you could call these my favorite vacation snaps. We had a lot of sort of things we did in high seas. We'd take a photograph every month, and then also at certain milestones. So like at 100 days or 200 days. In the top left, we did sort of on mission day 300, we did a spoof of the movie poster for the movie 300. These facilities are very small, and so I've got a video which I show whenever I'm in person, but you see one of the bunks in Hera, and the Hera bunks are just tall enough that you've got enough room to sit up in it, but not stand. And so the bottom left is one of our crew bunks, and for the last mission day, we wanted to cram everybody into one bunk and take a selfie, and so that's what we've got going on down there. Anyway, that brings the presentation I had to a close, but I like to kind of answer the questions y'all have as well, because I want to make sure I'm answering anything you guys want to hear about as well. So I'm happy to take whatever questions you guys have.
How long would it take to make the trip to Mars?
How long would it take to make the trip to Mars? That's a great question. This is a lot of what's driving the study right now. Right now it takes, depending on the trajectory you take, 6 or 7 months to get there, and then 6 or 7 months back. But you can't just leave whenever you want. You have to wait for the planets to align, because whenever you come back, you kind of have to shoot in such a way that whenever you get there, Earth arrives at the same point that you do. And so it turns out, in order to line that up, it's an 18-month stay on the surface. So you put it together, and it ends up being about a 2.5-year mission round trip. And so that's what's driving kind of a lot of the research right now, is because we have to have a crew who is supported, so has all the supplies they need, plus whatever backups in case something goes bad. And so they need to be able to fix that, but they also have to be able to kind of tolerate each other for 2.5 years as well, and work together as a team for that whole time. I'm trying to
How big of a ship would you need in order to carry all the supplies necessary for that size crew for 2.5 years?
That's a good question. I'm not sure I actually know the answer to that one, so I don't want to give a false answer here. What I do know is kind of the what they're looking at. There's what's called a design reference mission. It's a document that NASA puts together, and it's kind of their first cut at what a Mars mission would look like. And so the way they're planning on doing it, from what I understand, if they stick to that design reference mission, is they're not just going to have supplies on the spaceship. They're actually going to send a couple of rockets ahead of time as well, and put supplies on the Martian surface as well, sort of break it up. From what I understand, I think it's, if you take at least sort of a couple of ISS modules and put them together and then add sort of engines to that, that's kind of the spacecraft that would get you to Mars. I believe it's something about that size. So it's much larger than the capsules we're looking to, or even the space shuttle. It'd be not quite the size of the ISS, but at least looking at a couple of sort of modules that size.
So is there any mechanism that you get to see or talk to your family while you're on a mission?
So for us, previous missions had tried to use radio signals, not radio, but something where you would talk into it and it would be communicated. And for Hera, we actually use that. And for the first couple of days of the Hera mission, we actually stayed at real time and worked with our mission controllers. And during that time, we could get phone calls. Not whenever we wanted, but there was a designated like half-hour time every couple of days where our friends and family could call a certain phone number, and they'd get patched into us, and we'd have what were called private family conferences. And they do that with the ISS as well. The ISS actually has satellite phones, so they can call you. I know flight controllers who've been sitting at dinner and gotten phone calls from the ISS. For high seas, though, we were at a 20-minute time delay for the whole mission, and they hadn't had a whole bunch of success with that voice system. So they had done away with that entirely by the time we got there. And so for us, it was all email and file transfer. So we could email things, and then we had servers that we could drop files onto. And so we had iPads, and so we'd record audio or videos and send those to family members, and they could record stuff and send it back. But aside from that, we weren't allowed to use phones, except for one instance. We did get to talk to Scott Kelly, who was on the space station doing his year in space. And he had heard about our mission and wanted to talk to us. And so our project admin weren't about to turn that down, so they justified it by saying it was a space-to-space link. But that was the only phone call we got for the whole year.
Did anyone get sick while y'all were on this mission?
Actually, no. For the most part, and that's what we're learning with social distancing right now, is if you put somebody in a small space and you don't let anybody come and go, there's no way for those viruses and bacteria to get in. So for high seas, for me, that was a year without flu or colds or anything like that. The only sort of illnesses that I got while I was there, I had one day where something I'd eaten didn't sit right with me, and so I had an upset stomach one day. And then about a month or two before I was getting set to come back to Earth, one of the things I wanted to make sure was that I was up on my shots. And so we actually had a dose of Tdap sent. And so I got my Tdap vaccine, and I had a bit of an immune reaction to that. And so I spent an afternoon in bed for that. But aside from that, there was no illness over the time of that mission because there was no way for it to get in.
You know, I had a thought in terms of logistics. If you think of the old railroad days where you had these whistle stop places where they would, along the way between here and San Francisco, there would be a place to stop and get water and coal and things like that. Instead of launching the supplies all the way to Mars and dropping them there to wait on people to follow, are there whistle stops that you could keep in space along the way and have them manned? And so maybe people would get off at a whistle stop and go on, and other people would get on and continue to work. It wasn't one trip, but it was a series of trips.
A little bit. There's a way to do that. So between Earth and Mars, it's very difficult to do because there's no fixed points in space. Everything's kind of orbiting and moving around. And so that makes it difficult to have one kind of between places unless you kind of build a trajectory to go somewhere else and then go to wherever you're going. Problem with that is more often than not, it ends up being a lot less efficient, uses a lot more fuel to do and things like that. But whenever you're at those planets, sometimes there are ways to do that. And so that's actually one thing we're trying to do around Earth is, I don't know if y'all have heard of sort of the Artemis missions we're doing at NASA. One of the things we're trying to do as part of that set of missions is create something called Gateway, which would be sort of a little miniature space station in orbit around the moon. And it's not that far from Earth, but what that does is you can kind of construct your spacecraft and get your crew ready to go there and then send them from there to go to Mars. The gravity is a bit lower there, so it takes a lot less fuel to leave the moon than it does Earth. And so not all that far out, but we are kind of at least have that sort of stop, as you said, a whistle stop kind of built into sort of our current concept of operations right now. That's something, so in the closer term, we want to do missions down to the moon, and that's the other thing we're looking at for Gateway, is using that as sort of a stopping point for our landers going down to the moon as well. And I was looking to see if I could bring up the, still got the slide. I'm going to stop sharing here. Did anybody put anything in the chat here? It doesn't look like. Oh, here's one. I'm kind of working upwards. I see James asked, did it ever come to blows or heavy arguments considering you were all together for a year? I won't say that it ever got to blows. We never got to violence, but we absolutely had arguments. And so the way I put it is, you know, take your brothers and sisters, or if you've been at college, take your college roommate and lock yourself in a house with them for a year and see how you come out the other side. And I'm seeing a couple of people in the video shaking their heads and things like that. You get it. Absolutely. And the problem is it's kind of a double-edged sword. Whenever you pick crews for a mission, you don't want to pick people who all think the same way. Part of that is, if the saying goes, if everybody's thinking the same way, that means somebody isn't thinking. Because you always want somebody who's thinking differently, who can kind of see problems from a different angle in case you're doing the wrong thing. You want somebody who can catch you and say, hey guys, have you considered this? So we look, whenever we put together a crew of people for spaceflight or anything like this, we look for a diverse sort of set of experiences, a diverse set of viewpoints and things like that to kind of get that diversity. The downside to that, though, is that's also what feeds arguments, is people view things differently. Even if you get people who are thinking the same way, everybody still has different life experiences and things like that. And so you get, and it turns out it's not even the big stuff. It turns out to be kind of all the little stuff. So things that we found out after the mission were called micro stressors. So we would argue over, the one I always talk about is how to do the dishes. We had some crew members who wanted to do the dishes after every meal and some who wanted to save them till the end of the day. And both had valid arguments, and that was a sticking point through the whole mission. Seems silly in hindsight, but at the time you're in this very sort of pressure cooker environment with no way to escape. And it's just these little things sooner or later bubble over. I'd say I'm kind of a much more blunt person now, and that's because the lesson I kind of took from that is you have to face your problems head on in there. You can't sit and hope stuff will go away, because it won't go away in there. There's nowhere for it to go. And so it's much better to face it while it's still small, rather than letting it kind of sit and boil and bubble and get worse. Let me see, I see. When do you think humans will go to Mars? Oh boy, that's a good question. I know we want to go kind of in the late 2020s to 2030s. It's always kind of, if you follow the history of NASA, it's always been kind of 20 years in the future. And a lot of that is, I think technologically we can do it. Excuse me. I think though it's always a political thing, because it takes a lot of money to do. There's got to be kind of the country's got to have the will to do it. And so because it takes money and it takes support from people as well. I mean, the way I put it is, this space program is your space program. It belongs to the taxpayers. And so it's what y'all want to do with the space program as well. Y'all have a say. Mars is difficult to do, and it does take a concentrated effort. So if we follow the plan we've got, I'd say early 2030s, but it all depends on sort of the political environment, things like that. See, I'm scrolling through questions. See, I believe that's all the questions I see in the chat. Were there any other questions in the group or anything like, how am I doing on time, by the way?
You're good. We maybe have time for one more, and then Joe will take it back.
Okay. Oh, here we go. What do I think of Space Force? I think oh boy, I think whenever people were talking about Space Force, people sort of envisioned sort of the sci-fi view of that, of, people going out with ray guns and things like that. And what it is in reality is, we've kind of taken this group of different military space units, and we're kind of trying to put it together kind of under one house. So, the Navy kind of has their own space operations. The Army has their own. National Reconnaissance Office has their own. And I think I can see where they're coming from on it. In real life, I mean, it's what space turns out to be for military in real life is things like the GPS constellation, or reconnaissance satellites, remote sensing, weather satellites, and things like that. And it's really kind of taking all these programs that are sitting under all these branches and kind of centralizing them. I think it's come out better than I think sort of, again, I think it was very sensationalized. I think people had a different view of what it was going to be, but this was sort of getting that all together and kind of organized and not splintered out so much. I don't think is a bad idea. I think it seems to be working pretty well so far.
Okay, thank you. Appreciate it, NJ, and for
Absolutely.
the listening program. I think that most of us, though, would look at the current need to stay home in a different way now. As a way to thank you for your time, for your talking with us, we will make a donation in your name in the Rotary Foundation End Polio Now campaign. And we'll have that for you. Time of closing, I want to please remember to read our Rotarygram that comes at email at the inbox every Monday. And I want to remind you, thank you all for attending our meeting today. And our tradition, let's close the meeting by saying the four-way test of the things that we think, say, and do. First,
Is it the truth?
True.
second,
Is it fair to all concerned?
third,
Will it build goodwill and better friendships?
fourth.
Be beneficial to all concerned.
Thank you. Have a good week. Go out and connect the world.
Thanks, Andres.
Thank you. We enjoyed it.
Awesome. Thank you all for having me.
This was great.
Have a great day.
Fantastic. Great presentation.
Thank you so much.
Outstanding. Very interesting. Good luck being in the States.
Hey, thank you much, everybody. And hopefully this goes to show, I mean, it's tough right now, but y'all can do this. It's a doable thing. There'll be an end to this, I promise.
Thank you.
Of course.
MJ for me, thank you very much.
Of course. Thank you for having me. Again, this was kind of the first one I've done since we've started having everything with the coronavirus and everything. So thank you for putting up with me while I've been kind of learning and such here too. So
no, we were grateful to have an eager person who was ready to get in this with us. So.
Yeah,
cool.
Great to have you here.
Well, glad to be here. Cool. Thank you so much.
Thank you.
Yeah.
Thank you.
Of course. Thank
Be
you.
safe, everyone.
There, hold on.